All right, this is page 3 of the balancing packet. So we're starting on number 25 here. As always, I'm going to start by doing my atom inventory. I have 1 phosphorus, 5 chlorines, I have 2 hydrogen and 1 oxygen. On this side, I'm going to do them in the same order. 1 phosphorus, chlorine, it appears I have 1. Hydrogen, I have 1 here and 3 here, so that's a total of 4 when you add them between the 2 different compounds. And then the oxygen, it appears I have 4 as well. Okay, phosphorus looks good. I have 5 chlorines and 1 chlorine, so if I put a 5 in front, the chlorine turns into 5, but it also affects my hydrogen, so I have 5 here plus these 3. I now have a total of 8. 8 hydrogen and 2 hydrogen. If I put a 4 in front of here, 2 times these 4 will give me 8. Now my oxygen turns into 4, and we're balanced. 1, 5, 8, 4 on both sides. 1, 4, 5, and 1 are the coefficients. Okay, atom inventory. 2 carbons, 2 hydrogen, 2 oxygen. On this side, 1 carbon, 2 hydrogens, and 3 oxygens. Okay, so I would start by probably putting a 2 here in for the carbon. This turns into 2. Oxygen, 2 times 2 is 4, plus that guy turns into 5. This is one of those cases where you look at this, okay, so carbon is good, hydrogen is good, the oxygen isn't. Okay, so the key is going to be this guy, because this is an oxygen that I can affect, or I can manipulate, and it's not going to affect, the other elements present. The only problem is that this is diatomic, so I have an O2. Well, this number is odd. Okay, there is no whole number times 2 that is odd, but there is a number that times 2 is 5. It happens to be a fractional number, which we can't have decimal numbers, but I'll show you how to fix that. So what we need here is actually 2.5, because 2.5 times 2 is 5, and that does balance it. And so how are we going to rid ourselves of that dastardly half? Well, we have to multiply everything by 2. We have to double it. So this 2.5 is going to become 5. This 1 becomes 2. This was a 2. It's going to become 4. This 1 becomes 2. Let's check our work real quick. So there's 4 carbon. Here's 4 carbon. Here's 4 hydrogens. Here's 4 hydrogens. Here's 10 oxygen. So I have 8 and 2. 10, it's balanced. So 2, 5, 4, and 2 are the coefficients. Okay, and this next one, we have 2 hydrogens, we have 2 oxygens over here, 2 hydrogens and 1 oxygen. I'd probably start by putting a 2 here. That's going to make my oxygen 2. It changes my hydrogen to 4. Put a 2 here. That changes it to 4. So 2, 1, 2 are the coefficients. For number 28, atom inventory. 2 nitrogens, 2 hydrogens. Oops. Over here, I have 1 nitrogen and 3 hydrogens. Okay, well, I could start by, let's see, we have 2 and 1, so if I flop a 2 there, that's going to make my nitrogen 2. Hydrogen's going to turn into 6. All I have to do then is put a 3 here, and 3 times 2 will give us 6. 1, 3, and 2 are the coefficients. For number 29, that isn't a typo. Sulfur is found in this octahedral form where there's 8 of them bonded together. So that's not a mistake. That is the correct formula. So on this side, I have 8 sulfurs, 2 oxygen. On this side, I have 1 sulfur and 3 oxygen. Okay, so I'm going to start balancing this guy. I'm going to go ahead and let's start by putting an 8 here. So this sulfur is going to become 8, and then 8 times 3, well, that's going to be 24 oxygens. That seems like a lot, but the sulfur is good. 2 and 24, you can fix that by simply putting a 12 in front of the diatomic oxygen. 12 times 2 is 24, 1, 12, and 8. For number 30, we have nitrogen, so we have 2 nitrogen, we have 2 oxygen. On this side, we have 2 nitrogen and 1 oxygen. If I flop a 2 in front of here, the oxygen turns into 2, the nitrogen turns into 4. All you have to do is put a 2 in front of this nitrogen, it becomes 4. So 2, 1, 2 are the coefficients. For number 31, we have 1 mercury here, we have 1 oxygen. On this side, 1 mercury and 2 oxygen. So putting 2 here will change these both to 2. All you have to do then is put a 2 in front of the mercury, 2, 2, and 1. For number 32, This one, you should be familiar with this guy. You've seen this. This is photosynthesis back from your days as being biologist. Let's do our inventory. I have 1 carbon. Oxygen, I have 2 here and 1 here, so a total of 3. Hydrogen, I have 2. On this side, carbons, it looks like I have a total of 6. Oxygens, I have 6 there and 2 there, so that's a total of 8. Hydrogen is 12. Okay, so all I have to do, let's see, I'd probably start by putting a 6 in front of here. That's going to balance my carbon, so that's 6. So I have 6 times 2 is 12, plus that one is now 13. You know what doesn't jazz me up? The numbers 13 and 8. I can't think of a single factor that both 13 and 8 go into, maybe with the exception of 13 times 8. I don't want to do that. So it's okay if you get numbers like this that don't look real fun to do. Sometimes there are much easier ones lurking. Okay, look at this one, 12 and 2. That's much easier. Okay, I can get 12 hydrogens by simply putting a 6 here. 6 times 2 is 12. And now our oxygens, we have 6 here, plus these 12. Well, this is now 18. Okay, looking at this, you might be like, oh man, 18 and 8, that still doesn't look very fun. But there's kind of a trick here. Because notice, I can get 18 over here. I'm not going to mess with these 6. All right, because the carbon and hydrogen are already good. So I need to come up with 18 on this side, but I'm not going to touch those 6. So if I get rid of those 6, that means I only need to come up with 12 from this O2. Well, 12 from O2 is pretty simple because all you have to do is slap a 6 here. 6 times 2 is 12, plus these additional 6. Lo and behold, there's 18. So the coefficients for this one are 6, 6, 1, 6. For 33, okay, we've got 1 zinc, 1 hydrogen, 1 chlorine. On this side, we have 1 zinc. Hydrogen, it looks like we have 2. Chlorine, it looks like we have 2. All you have to do is place a 2 there. Hydrogen and chlorine both become 2. 1, 2, 1, 1 are the coefficients. For number 34, I have 1 silicon. I have 4 chlorines, 2 hydrogen, and 1 oxygen as reactants. On the other side, silicon, it looks like we have 1. Chlorine, we have 1. Let's see, hydrogen, I have 4 here, plus this guy, so we have a total of 5. And then oxygen, we have 4. All right, so silicon is good. Chlorine, we have 4 and 1, so if I flop a 4 in front of here, chlorine becomes 4. Hydrogen, we have 4 here, plus these 4, we have a total of, 8. This one's still 4. Okay, that looks good. Hydrogen, we have 8 and we have 2. If I put a 4 in front of here, this becomes 8. Oxygen turns into 4. Okay, hey, we just fixed it. So 1, 4, 1, 4 are the coefficients. Okay, and this next one, we've got 1 sodium. We've got 2 hydrogen. We've got 1 oxygen. On this side, looks like 1 sodium. Hydrogen, we have a total of 3. We have 2 here and 1 here, so 3 hydrogen and only 1 oxygen. Okay, so in this instance, taking a look at this, a couple of ways you could think about this. One way, you could see, well, everything's good except for hydrogen. I've got 2 and I've got 3. Usually 2 and 3, the common factor is going to be 6, but in this instance, you're going to find 6 doesn't work. Because the 3 are separate, meaning I have 2 here, then a lone one here, the common factor is going to end up actually being 4. Okay, how do I know that? I just have to kind of remember that. Hey, so how am I going to end up getting 4 hydrogen on this side? Well, if I put a 2 here, you've got 2 plus these 2 makes 4. Oxygen turns into 2. Sodium turns into 2. Okay, how do I get 4 hydrogen on this side? Put a 2 here. This becomes 4, oxygen becomes 2. Then you just slap a 2 in front of the sodium, and it's good. So we have 2, 2, 2, and 1. Alternatively, there's another way you could think about this one. I'll show you. It's dealing with halves. So that way works. You can also think of it like this. Hey, if I have 1 sodium, let's see, 2 hydrogen, and I said 1 oxygen. Over here is 1 sodium. Hydrogen, we have a total of 3 hydrogen and 1 oxygen. Okay, well, if we could just do this and get rid of that 2, this is now balanced. The only problem is we can't just scratch out that 2. Okay, hydrogen's diatomic. It's always found in pairs. So there's a mathematical way we can get rid of that 2. We can use a half. because half of 2 is 1. And so now we have 1 and 1, so that's 2. It's now balanced. The only problem is you can't use halves. How do we rid ourselves of that half? We double everything. So 1 half doubled is 1, 1 doubled is 2, 1 doubled is 2, 1 doubled is 2, 2, 2, 2, 1. Same answer either way. Okay, number 36. Let's take a look here. So we have 3 hydrogens. We have 1 phosphorus. We have 4 oxygen. On this side, hydrogens, we've got 4 and 2, so we have a total of 6. Phosphorus, it looks like we have 2. Oxygen, we have 7 and 1, so that's a total of 8. This one's actually pretty straightforward. You just slap a 2 there. Hydrogen becomes 6. Phosphorus becomes 2. Oxygen becomes 8. Lo and behold, we're balanced. So 2, 1, 1. Okay, this next one. So this would be decane. The combustion, or no, this isn't combustion, but regardless. We've got 10 carbons. We have 16 hydrogens and 2 chlorines. On this side, we have 1 carbon. Hydrogens, we have 1. Chlorines, we have 1. Okay, well, let's see. I'm going to skip carbon for right now because I can put any number in front of there and balance it because it's all by itself. Let's look at this. So I have 16 and 1. If I put 16 in front of here, hydrogen becomes 16. Chlorine also becomes 16. I can easily make chlorines 16 by putting an 8 there. That turns into 16. And lo and behold, it wouldn't have mattered. I could have put a 10 here in the beginning and it wouldn't have affected things one way or the other. 1, 8, 10, and 16.